Now let's see the multiplication of matrices. So if we have two matrices A and B, they are suitable for multiplication, as in A multiplied by B, if the number of columns of A is equal to the number of rows of B. So A multiplied by B is only possible when the number of columns of A is equal to the number of rows of B. Now see this example here. A here is of the order 2 by 3, so 2 rows and 3 columns. And B here is of the order 3 by 3, so 3 rows and 3 columns. The number of columns of A is equal to the number of rows of B. So A multiplied by B is indeed feasible. Now let's see how the multiplication actually happens. So let's take a look at a simpler example first. Let's say matrix A here is 1 and 2. Let's say matrix B here is 1 and 3. So we want to find A multiplied by B. So first let's see if they are suitable for multiplication. Matrix A is of the order 1 by 2. Matrix B is of the order 2 by 1. So matrix A has 2 columns and matrix B has 2 rows. So the number of columns of A is equal to the number of rows of B. So A and B are suitable for multiplication. Now to actually multiply A and B, what you'll simply do is multiply the rows of A into the columns of B. That's really about it. So you'll multiply 1 and 1, add it with 2 multiplied by 3. And the resultant matrix will be 1 plus 6, which is this here. Now, a very handy way of a trick of finding the to confirm the order of the resultant matrix. So 7 here is of the order 1 by 1. To actually see if this is actually the correct order, you'll just simply find these two numbers. The resultant matrix must have the number of rows of the first matrix, which is A here, and the number of columns of the second matrix, which is B here. So 1 by 1. Let's see a more advanced example. Let's find A multiplied by B. First, let's see if they are suitable for multiplication. So A here is of the order 2 by 2. B here is also of the order 2 by 2. So the number of columns of A is equal to the number of rows of B. So they're indeed suitable for multiplication. And the resultant matrix will be of the order 2 by 2 because it will have the number of rows of A and the number of columns of B. So let's just see. See here, this matrix is of the order 2 by 2. Now how did we find this? Simple. You'll first multiply the first row of A into the first column of B. So 2 multiplied by 1 plus 3 multiplied by 6. Now the second element, simple. You'll first multiply the same first row of A into the second column of B. So 2 multiplied by 7 plus 3 multiplied by 4. Now this is getting a bit messy here. Let's erase these lines. Now the third element of the resultant matrix, that will be found by multiplying the second row of A and the first column of B. So 1 multiplied by 1 plus 5 multiplied by 6. Now the last element, of course, will be found by multiplying the second row of A and the second column of B. So 1 multiplied by 7 plus 5 multiplied by 4. This is the answer of A multiplied by B.